Okay, so let's start our first problem. Follow along on the conversion quiz review sheet if you have done so. If not, use this for extra practice and you can go ahead and try and solve each of these problems. So find the molar mass for potassium sulfate. We know potassium on the periodic table has a mass of 39 grams, and sulfur has 32 grams. Oxygen is 16. Now we can see in potassium here has 2, so we're going to multiply that by 2. We are going to multiply sulfur by 1 because there's only 1. We're going to multiply oxygen by 4 because there are 4. We end up having 78 grams, 32 grams of sulfur, and 64 grams of oxygen. We add all that up, we get 174 grams, and that right there is the molar mass of potassium sulfate. Let's go to copper oxide. Relatively simple, right? The invisible subscripts, we have 1 of each of these. So copper has a mass of 64, oxygen 16. Just going to add those up. That's 80 grams. Now let's continue this process, right? We are still finding the molar mass. So magnesium, we have 24 grams. Arsenic is 75 grams for its molar mass, and oxygen is 16 grams. Alright, now we see that magnesium we have 3. So multiply by 3. Remember this 2 goes into arsenic, so 2 times the invisible 1 right here, and 2 times 4 for oxygen give us 8, so 16 times 8. We multiply those out. Magnesium ends up being 72 grams. Arsenic is 150 grams. And oxygen is 128 grams. Add all those up, and we end up having a molar mass of 350 grams for this compound. Continuing on, once again, continue the process we've been using for the last 3 equations, right? The reason I set up my equations this way is it's just easier for me to think through all of these equations. You feel free to set up however you would like, okay? The math should all be the same. So we have calcium at 40 grams, phosphorus at 31 grams, and oxygen at 16 grams. Remember, these can all be found on the periodic table. Calcium, we have 3. Once again, let's multiply that 2 into the phosphate. Let's multiply this 2 into 4, so we have 8 oxygen. Now let's find our totals. So calcium is 120 grams, phosphorus is 62 grams, and oxygen is 128 grams. Once again, add them all up. We have 310 grams as the molar mass. For iron oxide, iron and oxygen. Iron has a mass number of 56, oxygen of 16. We're going to multiply that by 2 because we have 2 irons, multiply by 3 because we have 3 oxygens, 112 grams of iron and 48 grams of oxygen. Add them up and get 160 grams for the molar mass of iron 3 oxide. Hopefully by now you're seeing a pattern and you have a grasp on how to do this yourself, but let's continue with the last 3. Aluminum hydroxide is composed of oxygen and hydrogen. Aluminum has a mass of 27. Oxygen, once again, is 16, and hydrogen is 1. Let's go ahead and multiply those by how many elements are in the compound. Aluminum, we just have 1. Simple math there. Multiply our oxygen by 3 and multiply our hydrogen by 3. Right? Oxygen, hydrogen. And our oxygen comes out to 48 grams and hydrogen 3. Add them up. We're at 78 grams. We have nitrogen, hydrogen, sulfur. Okay, nitrogen molecular weight can be rounded to 14. Hydrogen 1, sulfur 32. And let's go ahead. Our 2 goes in. We have 2 nitrogen, so times 2. And we have 2 times 4 is 8 hydrogen. Sulfur all by itself. So now we come out to 28 grams of nitrogen, 8 grams of hydrogen, and 32 grams. 2 grams of sulfur. Add them all up. 68 grams is the molar mass. Last but not least, carbon, hydrogen, and oxygen. That's supposed to be a full O. There we go. Carbon will be 12 times 12, right? 12 grams is the molar mass. 1 hydrogen in grams times 22, and oxygen 16 grams, and we have 12 of those. A little simple multiplication, we have 144 grams. Hydrogen, we have 22 grams. And oxygen, we have 192 grams. Add them all up, this compound has a molar mass of 358 grams. Now let's convert the following, to moles. So we have 60 grams of sodium hydroxide. First thing we're going to find is the molar mass of this compound. And if you don't know how to do that, see the previous about 8 minutes of this video. But sodium hydroxide ends up being 40 grams for its molar mass. Alright, now that we have that, we can do this 2 ways. So we're starting with 60 grams. And we know that in 1 mole, which is where we're trying to go, we're going to moles, we have 40 grams. Alright, so it ends up being our grams cancel. Let's do that. Our grams cancel, and we're left with moles. And that's going to give us 1.5 moles of sodium hydroxide. You can also do this equation if you don't like the train tracks method. Well, you know that you have 60 grams, right? Sodium hydroxide. Well, you figured out the molar mass up top, okay? And we end up having 40 grams per mole. Right, this means our grams cancel. It's the exact same math as above. It's just written out differently and will give you the exact same answer. Once again, we're converting grams to moles. Alright, so once again, start in the exact same place, finding the molar mass. Right, we find the molar mass to be 110 grams. So we have 1.7 grams. 110 grams in 1 mole. Our grams cancel out, and that's going to give us 0.0518 moles. You may report this as 10 to the negative second, 5.2 times 10 to the negative second moles as well. Both answers are acceptable. Let's convert the following to grams. So we have a very small amount of moles of carbon dioxide, but once again, need to find the molar mass. After using our periodic table and addition, we find out that this is 44 grams. Alright. So this time we're going to start with 0.100 moles. If you want to write this as 0.1 moles, that's perfectly fine as well. Okay, now we know that 1 mole, and moles are down on the bottom, so we can cancel. We have 44 grams. Alright, so now we're just going to multiply 0.1 times 44, and that's going to give us 4.4 grams of CO2. Let's go ahead, continue our conversions. Okay, we have zinc chloride. Once again, we're going to need the molar mass because grams are in the equation, right? So the molar mass turns out to be 135 grams. So now we have 3 moles. Let's go ahead and say that in 1 mole of zinc chloride, we have 135 grams. Once again, our moles cancel out, and all we're left with is multiplying 3 times 135 grams, and that's going to go ahead and give us 405 grams of zinc chloride. Now, we're going to molecules. As you can see, we have a compound here. We have 6 moles of that compound, but we do not need to find out grams. So if you did this correctly, your equation would have set up something like this. We'd have 6 moles, alright, and we know that at 1 mole there are 6.02 times 10 to the 23rd molecules for every single compound on the element on the periodic table. So what do? 6 times Avogadro's number. Let's make sure I have enough space to write our answer, which will be 3.61 times 10 to the 24th